Alright, so we're continuing our video solutions to exam number 1, and I wanted to make sure we were starting the first full response problem. And we're going to go ahead and finish it on the next page. And the next question says, write the mathematical equation that represents the position of this object. So, in general, you're going to be marked wrong if your equation looks like this. Wrong. This is not algebra class. You are expected to know algebra fluently, but this is physics class. So you are actually expected to write something in the form of the Buggy Lab equation, and it should look like this. So let's go ahead and fill in some of these letters. First of all, x and t are going to be variables in this problem. These are positions that we calculate as a function of time. And what I want to get is this and this. And if you remember from our Buggy Lab and our calculation, v0 is the slope, which is m, and x0 is our y-intercept. So when we go ahead and calculate this, what we're actually going to get for our answer is x equals, we go to the previous page, aha, this is the slope, and there's the y-intercept right there, here, and here. So let's go ahead and put those into our formula. So we end up getting x equals 7 times t plus 10. That's the formula. That is the answer you are expected to come up with. Now it says, where will the object be at 15 seconds? That's the whole point of coming up with this formula. I can't read it off the graph, because at 15, like the graph cuts off at 10. So where will it be at 15? The way you get that is you say x equals 7, and you plug in 15 for time, and you get your answer. So that ends up being 105 plus 10 when you do the math. And that works out to being 115 meters from the origin. That's our position. Now, continuing on, we have a police car sitting at a stop sign and it notices a speeder moving ahead at 25 meters per second. And the car then moves at 30 meters per second to catch a speeder, and we want to answer some questions. So first, let's just figure out what's going on here by drawing a qualitative graph. So what are we saying? What we're saying is we have position versus time. I will draw the police car in blue. And you know what? Just because some of you may print this in black and white, I'm going to do this. I will make the police car a dashed blue line. And I will make the speeder car a solid red line. And, sorry, just get rid of that. I'm going to make the speeder a solid red line. Now what's happening? Again, at 300 meters, that's where the speeder is. So what's happening is the speeder is moving forward at one speed, and the police car starts at the origin 300 meters behind, and it eventually catches up to the speeder by traveling at a constant rate to catch up to it. So this is the police car, and this is the speeder right there. Now it says, how can we tell which car is moving faster? By looking at the graph. People came up with a lot of nonsense on this. Let's be very clear. The police car is faster because the slope of its position graph is steeper. That's it. Alright? Now, write down the equation for the police car's position versus time. That's going to be x for the police car equals, and I put a little subscript there for the police. Its speed is given at 30 meters per second times t, and it starts at the origin, so that's plus 0. And then for the speeder, x of the speeder is going to be 25 times time plus 300 meters. Then it gets us the head start because it starts here at 300. Now what's going to happen is, how do I use these two answers to determine what's going on? Again, these are not things that we always cover in class. You are expected to use your God-given intelligence, even though nobody's ever shown you how to do this. Yes, this is what happens in real physics. You are expected to do some of your own original creative thinking that no one told you how to do. To realize they meet at the same position, which means if they meet at the same position, the way you express that mathematically is that the position of the police car is the same as the position of the speeder when they meet. So you set those two things equal to each other, and you get that 30t equals 25t plus 300. Now, I can do some math. I can subtract 25t from both sides. I'll get 5t equals 300. And finally, I will get t is 60 seconds. That is when they meet. So where do they meet? The way to get that is I will now get the police car equation, and I will plug 60 into it. So I will take x police equals 30 times t, which is 30 times 60. So they meet at a position of 1,800 meters from the starting point of the police car. Now, here we go. A bird can fly 25 kilometers per hour. How long does it take to fly 18 kilometers? A couple of formulas will work. I'll use this one. X equals V naught T plus X naught. They don't give me X naught, so I'll assume it's 0. So I have 18 equals 25 T plus X naught. So my time is going to be 18 divided by 45 hours. Okay? Sorry, 18 divided by 25 is my hours. And then what I can do is I can go ahead and use this to get the hours, but here's the deal. I want this answer in seconds, so I'm going to, or in minutes. So I will take 60 minutes over 1 hour using my bubble method to convert. So when I go ahead and calculate that, what I'm going to end up getting is I will get 18 times 12 over 5. So what I did here is I did a little math work here. I want to be kind of clear on this. There's a little math here that I did some simplifying of some fractions. So if you don't see that, I'm sorry, but I can't teach you third grade math again. So I've simplified a fraction. So this is going to be 180 plus 36 divided by 5. Again, I'm doing a little math here, so you're just going to have to follow along. So that ends up being 216 divided by 5. So when I actually calculate that out, this time is going to work out to be about 43 minutes. Okay, so I did a little bit of algebra there, and I did a little bit of arithmetic there, and it's not, I didn't explain exactly what I did, so you're going to have to go and do the legwork of reviewing all that little middle school algebra and all that grammar school algebra, because that's you need to be fluent in it. Okay, so now, you are traveling at 50 kilometers an hour. That's your V naught. You have a time of 4 seconds, and you want to know how long you travel, but you've got to do some unit conversions. So I'm going to convert kilometers per hour to meters per second. That's the first thing I'm going to do. So that's going to be 50 kilometers per hour. And I'm going to convert, 1,000 meters over 1 kilometer to cancel my kilometers. And then to convert hours, one more little conversion. I actually have, in 1 hour, I have 60 seconds in a minute and 60 minutes in an hour. So this works out to 3,600 seconds. And then that'll be my converted velocity, and I'm going to use that to get my position in a second. And of course, when I do my conversion, I end up getting 13.89 seconds. Sorry, 13.89 meters per second. And now I'm going to use x equals v naught t plus x naught, which is 0. So I'm going to get x equals 13.89 times the 4 seconds that I travel. So 13.89 times 4 actually ends up giving me 55.56 meters, which I think ends up being something like around 200 feet, that you travel. So don't drive and text. That's kind of the moral of that one. No. A person jogs 8 complete laps around a 400-meter track in a total time of 13.5 minutes. So the distance is going to simply be 400 meters for the whole track distance times 8 laps around it, so that's 3,200 meters. We didn't exactly have a formula for that. You're expected to use your 7th grade math skills to come up with that idea, because you do things like this. I go around 1 circle, 400 meters, 8 circles, 3,200 meters. What was their displacement? Again, displacement is x final minus x initial, and this actually ties back into, if you flip your exam back to the multiple choice question, if I have this right, it should be question number 4 on the multiple choice. So let's just flip back to the problem. Make it 0. And that's how we also are getting 0 meters. Now the runner's average speed, we can do meters per minute if you want. I'm fine with that. So why don't we do that? So we'll do v is the distance. So the speed is going to be the distance over the time, which will be 3,200 meters. And you know what? Now let's just do this. So 13.5 minutes. That'll be 13.5 times 60. So we're going to do meters per second. So 3,200 divided by 13 times 60. Notice I put that in parentheses. And that ends up giving me something like 3.95 meters per second. That seems kind of fast, but hey, what are you going to do? And then we went over the runner's average velocity. That's displacement over time. And that's 0 over time, which is 0 meters per second. So that's pretty much it for exam 1. And I'm going to actually have these solutions posted as well. So good luck and happy studying.